Welcome to this video on experimental studies in epidemiology based on Chapter 8 of Introduction to Epidemiology by Merrill. In previous chapters, we focused on observational studies where researchers simply observe patterns in existing data. This chapter shifts into experimental studies where researchers introduce an intervention to test its impact. Experimental designs are powerful tools for determining causality, especially when properly randomized and controlled. What are experimental studies? Experimental studies involve manipulating exposure to determine whether it causes or prevents a health outcome. These studies are also called intervention studies. The basic idea is this: researchers assign participants to either receive an intervention or serve as a control, and then compare health outcomes. Experimental studies are ideal for evaluating the efficacy of treatments or preventive strategies, establishing cause and effect relationships, reducing the influence of confounding variables through randomization. When well designed, they are considered the gold standard of epidemiologic research. Randomization in experimental studies. The first key principle of experimental studies is randomization. Randomization means that participants are assigned to the intervention or control group by chance, not by choice. The purpose of randomization is to ensure groups are comparable at baseline, eliminate selection bias, control for unknown confounding variables. This process can be as simple as a coin flip or as complex as computer-generated random sequences. When done correctly, randomization helps ensure that differences in outcome can be attributed to the intervention itself. Blinding in experimental research. The second key principle is blinding, which means keeping participants or investigators unaware of which group the subject is in. There are three levels of blinding. The first is single blind, where only the participant does not know which group they are in. The second is double blind, where both the participant and the investigator are unaware. The third is triple blind, where even those analyzing the data are blinded. Blinding is important because it reduces placebo effects, minimizes observer bias, improves the validity of the results. Types of experimental study designs. There are several types of experimental designs used in epidemiology. The first is the randomized controlled trial. This is a clinical epidemiologic experiment where participants are randomly assigned to receive an intervention or control. RCTs are commonly used to test new drugs or preventive strategies. The second is the community trial, where entire groups or communities are assigned to intervention or control conditions. This design is useful when individual randomization is not possible, such as fluoridation of drinking water or anti-smoking campaigns in schools. The third is the quasi-experimental study, which lacks full randomization but still involves an intervention. It is often used when ethical or practical constraints prevent random assignment. Each design has strengths and weaknesses, but all aim to determine whether an intervention works. Key features of randomized controlled trials. A high-quality RCT has several important components. The first is a clearly defined study population with inclusion and exclusion criteria. The second is a process of random assignment to the test or control group. The third is blinding to reduce bias. The fourth is comparable measurement of outcomes between groups. The fifth is compliance, meaning participants adhere to the assigned treatment or protocol. RCTs may also include pilot studies, placebos, and ethical safeguards to protect participants. Advantages and disadvantages of RCTs. Randomized controlled trials offer several advantages. The first is that they eliminate conscious and unconscious bias in group assignment. The second is that they average out unknown confounding variables, increasing internal validity. The third is that they provide strong evidence for causality. However, RCTs also have disadvantages. The first is that they can be costly and time-consuming. The second is that they may raise ethical concerns, especially when withholding a potentially beneficial treatment. The third is that they sometimes lack generalizability to real-world settings. Phases of clinical trials, drug trials, and many other interventions follow distinct phases. The first is phase 1, which tests the safety of a new treatment in a small group of people. The second is phase 2, which evaluates dosage, tolerability, and side effects. The third is phase 3, which involves large scale testing to assess efficacy and compare with existing treatments. The fourth is phase IV, which monitors long term effects after the treatment has been approved and released. Each phase builds on the last to ensure that interventions are both safe and effective. Ethical considerations in experimental research ethics are central to all experimental studies. Key ethical principles include maximizing benefits and minimizing harm, ensuring informed consent, providing the right to withdraw at any time, using equitable selection of participants, protecting vulnerable populations such as children or those with disabilities. Controversial studies in history, like the Tuskegee syphilis study, highlight what can go wrong when ethical principles are violated. Modern trials are overseen by institutional review boards or IRBs, which ensure that studies meet ethical standards. Let's recap the key points. Experimental studies involve actively introducing an intervention to study its effects. Randomization and blinding are essential tools to reduce bias. Study designs include randomized controlled trials, community trials, and quasi-experiments. Clinical trials follow 4 phases to ensure safety and effectiveness. Ethical standards protect the rights, dignity, and welfare of participants. Thanks for watching. Join us in Chapter 9, where we explore causality in epidemiology, including how to infer cause from observed associations.